Okay, this should be the rest of 6.4. I think I have it figured out, but we will see because it's a learning curve. Okay, we're going to talk about scalar multiplication now. Scalar multiplication you're going to like and you're going to think it's easy. Basically, what scalar multiplication is about is if they tell you something like 4a, that's the same thing as a plus a plus a plus a. You're taking that matrix and adding it to itself 4 times. Well, instead, you could just take 4 times that matrix A and like distribute it into all the pieces because that's the same thing that would happen here. So the number you're multiplying by is called the scalar, and basically we're just going to distribute. So we're going to look at an example here. So we're going to take 3a and negative 1a. So if I take 3a, if I take 3 times this matrix A, I'm still going to get the same size as matrix A. And we're just going to like distribute this guy all the way in everywhere. So it's negative 9, 0, 12, and 15. So 3a would be this guy. Same thing as adding it to itself 3 times. If I take negative 1 times a, it's just changing all the signs of matrix A, right? Negative 1 times all those signs. So it'll be 3, 0, negative 4, and negative 5. Okay, scalar multiplication is pretty easy. What else do I have for you? Okay. Now, when you add and subtract, this is telling you that when you add, order does not matter. When you add, you can add the first 2 and then the last ones. Doesn't matter. You can take the scalar times the matrix or the matrix times the scalar. Addition is not the problem. Distributing, you can distribute to all the guys. There's something called a 0 matrix. It's just zeros in all the spots. You can add that and it won't change something. And if you take the opposite of a matrix and add it to a matrix, you're going to get 0. Those things are kind of common sense. Now, matrix multiplication is tough. You're probably going to want to use your technology on this, but I'm going to show you how to do it by hand first because on the small ones, it's easier by hand. First of all, it's going to be called row by column multiplication. And my rule for this is if it's a smaller matrix, I do it by hand. But if it's much bigger than like a 3 by something, then a lot of times I use technology. So I'm going to show you both here. And here is our examples. Okay, so things you need to know about matrix multiplication. First of all, not all matrices can be multiplied. So to multiply, the first matrix column must match the second matrix row. So what does that even mean? Well, we're going to look at these examples. So we're not going to multiply them first. I'm going to say, can they be multiplied? And if they can, what will the dimension be? If yes, what will the dimension be? Or the size? Because I'm running out of space. Okay, so what happens is, and this is what this is meaning, like say I have a 3 by 4 matrix. This matrix column must match the matrix that's multiplying by with row. So it can be multiplied with a 4 by 5, even though those are not the same size. This is what must match. The resulting matrix will be what is left. So the solution, when I multiply these guys, will be a 3 by 5. So interestingly enough, a 3 by 4 cannot be multiplied with another 3 by 4. Even though those are the same size, we can add them. Those do not match, so you cannot multiply them. So that's what we're going to do here. We're going to look at some of this. Can they be multiplied? So A times B. Well, A is a 2 by 3. B is a 3 by 2. So can they be multiplied? There's the match. The answer is yes. And the result will be what's left, a 2 by 2. Can B times A be multiplied? Well, B, we just said, is a 3 by 2. A is a 2 by 3. Match, the answer is yes, and the answer will be a 3 by 3. So you get different size matrix if you multiply them in different order. So they will not be the same answer if you change the order. Okay, how about B times C? B is a 3 by 2. C is a 2 by 2. They can be multiplied, and the answer will be a 3 by 2. Okay, and A times C. A is a 2 by 3. C is a 2 by 2. These cannot work, can't be multiplied. Okay, so the first thing you have to do is say, can they be multiplied? And after they can be multiplied, we do this thing called row by column multiplication. And I'm going to do 2 of them with you by hand, and then the rest we'll use our technology on. I don't know why I did that. Okay, so we're going to do A times B. So I'm going to write them out so that I can see them here. So I have 3. Okay, so it's called row by column multiplication. So we're going to take this row and we're going to multiply it by this column. And remember, we already figured out what the size is going to be. This is a 2 by 3. This is a 3 by 2. So my answer is going to be a 2 by 2. And the way it works is you got to picture this row coming over here to this column. So like the 3 is here, and the 1 is here, and the -1 is here. And you'll multiply the pieces by each other, but then you're going to add those. So we're going to take the 3 times the 1 plus the 1 times the 3 plus the -1 times the -2. So I get 3 plus 3 plus 2. And in this first piece, it'll be 3 plus 3 plus 2. That'll be 8. So that row by column. You got to finish the whole row before you go on to the next row. So now it's a row by this column, and it will go in this spot. 3 times 6 is 18, plus 1 times -5 is -5. -1, you can barely tell it's a -1. -1 times 4 is -4. So 18 minus 9 is 9. So you did that row. Now we're going to go to the next row. This guy here. Okay, so now you picture this 203 coming over. Okay, so I have the 2 times the 1, the 0 times the 3, and the 3 times the -2, which is -4 in this spot. The 2 times the 6, the 0 times the -5, and the 3 times the 4. So that's 24. Okay, so that is the answer. I can show you with the technology. Let me pull this up. I don't know what I want to do here. I guess I'll just erase it all. Okay. Okay, so what I have here, we're going to go to second matrix, and we're going to enter in matrix A. So go to edit A. Okay, I already forgot what it was. It is a 2 by 3. So I'm going to go across first so I can remember my pieces. 3, 1, -1. 3, 1, -1. 203. Okay, there's matrix A. So then go to second matrix. We'll go to edit. We'll edit matrix B. B was a 3 by 2. Go back to see what I got here. 1, 6, 3, negative 5. And then the last two, negative 2, 4. Okay. So second quit, because we're going to multiply those guys. So take second matrix. Now I'm going to select A times second matrix. I'm going to select B. And there's the same answer I got before. Now, it does take some time entering these in, so you have to decide, like, am I going to type them all in? That takes some time, or am I going to do it by hand? This video is lasting a little bit longer than I thought, so I'm actually not going to do another one. If you'd like me to do another video of doing those by hand, please ask me. Okay, let's look at, what does that say? The same thing we already talked about. Okay, so the word problems. This is a spreadsheet, and if you look, they made it, you can make it into a matrix. So this is where you might use matrix multiplication. If you have this matrix, just like it is a 2 by 3. They tell you a little bit of fact here in our bakery table here. It says the profit they make. They make $5 on bagels and $6 on donuts. Okay, sorry, my phone rang and I answered it. So this is a 2 by 3, and I need to put this $5 and $6 to see how much like money each store made. Well, the only way I could take a $5 and $6 and turn it into matrix would be if it looked like this, 5, 6, or if it looked like this, 5, 6. Well, if I'm going to multiply it, I needed the 2 to be in the second spot. So I'm going to have to use this guy, this 5, 6, and I'm going to have to put it in the first spot. So 5, 6 times this guy. And if you see, what happens is then this 5 would rotate over and the 6 would rotate down, and you'd multiply and you take 5 times 25, 5 times 30, 5 times 20. You would add them together and it would tell me the total profit each store would give me. Because this is a 1 by 2, this is a 2 by 3. So my answer is going to be a 1 by 3. And in this first spot would be how much, did I do that wrong? 1 by 2, 2 by 3, 1 by 3. Yeah, it would be how much profit the Main Street store brought me. So I would take this 5 times this 25 plus the 6 times the 40. 5 times 25 plus 6 times 40. And that's how much money this Main Street store brought in. 5 times, I'm in 365. So that's how much profit the first store brought in. Then in the second spot would be 5 times 30 plus 6 times 35. They made 360 at the Avon Road. And then the last guy doesn't look like he made as much, does it? $190. So then it can keep track of how much profit you made at your different stores. We're almost done, and I'm sure not everyone is even watching at this point. Matrix equations. This is discussed in your video for solving. We could turn systems of equations into a matrix equation if you put zeros in the right spot. And you can solve using your calculator. This would be a calculator problem. You would type, oh, I didn't know why I put a line there. You will type this matrix into your A and this guy into your B, and you could solve the system by A inverse B. You need to watch the review video if you want a good example of that. Okay, that's it.